Hi guys, welcome to this course on NEET 2017. And so let us begin our journey with of the physics question that appeared in NEET 2017. So today in this lesson we are going to discuss question number 125 that appeared in the physics paper, physics section of NEET 2017, and I am Vikas Joshi. So now let us begin our journey. Okay, so what does the first question says? Okay, Priti reached the metro station and found that the escalator was not working. She walked up the stationary escalator in time t1. On other days, if she remains stationary on the moving escalator, then the escalator takes her up in time t2. The time taken by her to walk up on the escalator will be. Okay, so now let us try to understand the question. What does the examiner want us to do? Okay, what does they want to find with this question? So uh, what is given? She walked up the stationary escalator in time t1, means the escalator is stopped, it is not working, and so time t1 is the time when she is walking, when Preeti is walking with her own speed, then she takes time t1. On the other hand, like if she remains stationary on the moving escalator, means she is stationary, she is not moving along with the running on the escalator or moving on the escalator, she remains stationary on the escalator and the escalator is moving with its own speed, then the escalator takes time t2 to cover the same distance. So uh, the basic thing that we need to keep in mind that the time taken to walk the let's say the distance d by Preeti herself would be T1 and by the escalator would be T2. So now it is asking that the what will the time taken by her to walk up on the moving escalator. What we all need to do is to find the time when she is also walking along with the escalator. So now let us look at the solution. Okay, let the speed of the Preeti be v1 and the distance the escalator takes is equal to d. So the time it is already given as mentioned in the question, it's t1, hence speed is equal to distance upon time, so v1 is equal to d upon t1. Now in the second case, when the escalator alone is moving, when the that is the case when Preeti is stationary on the escalator, so the speed of the escalator let be v2 and the distance would remain the same as d and the time is given t2. So again with the formula, speed is equal to distance upon time, v2 is equal to d upon t2. Now the question in the question it is asked that when she moves along with the escalator, now so what will be the time taken? So net speed will become v1 plus v2. So let us take the distance d that she needs to cover and the total time t that she needs to cover while moving along with the escalator. So again speed is equal to distance upon time, d upon t is equal to v1 plus v2. Put the value of v1 plus v2 from here, d upon t1 plus d upon t2. D get cancelled from both the sides and we get is 1 upon t is equal to 1 upon t1 plus 1 upon t2. Upon solving this we will get t is equal to t1 t2 upon t1 plus t2. That is our second option. Okay, that is quite a simple problem. It will hardly take you 30 seconds to solve this problem if your concepts are clear. Okay, so now let's move on to the next question. Okay, so what does the next question says? It says that the x and y coordinates of a particle at any time are x equal to 5t minus 2t square and y is equal to 10t respectively, where x and y are in meter and t is in second. The acceleration of the particle at t is equal to 2 seconds. Four options are given: 5 meter per second square, minus 4 meter per second square, minus 8 meter per second square, and 0. So what is the basic logic that we need to apply is, since it is given in the variables, we need to find the since acceleration is asked, so from the coordinates we need to find the velocity, and from the velocity again we need to find the acceleration. How we are going to do that? Differentiate this and this x and y part separately to get the velocity along the x component and the y component. Again differentiate that to get the acceleration along the x-axis and the y-axis, and add them to get the net acceleration. Okay, so now let us look at the solution. X is given as 5t minus 2t square, y is given as 10t. Differentiating will give us the velocity. So velocity along the x axis is equal to dx by dt, and if you are going to differentiate this, it will give us 5 minus 4t. I think you are quite clear with the differentiation concepts, so no need to recite them here. So now let us look at the velocity in the y-axis. Y-axis will become dy by dt, and since it is 20, so differentiation becomes 10. Now again we are differentiating this vx to get the acceleration along the x-axis. So dvx by dt is equal to minus 4. Since 5 is constant, it will become 0. Again differentiating vy with respect to dt, so we'll get acceleration along the y-axis. Since 10 is constant, so we'll get 0, and adding that we get the net acceleration, that is minus 4 meter per second square. That is our second option. Okay, that is our second option. So now that is also quite an easy problem. Okay, if your concepts are clear. So now let us look at the next problem. A rope is wound around a hollow cylinder of mass 3 kg and radius 40 centimeter. What is the angular acceleration of the cylinder if the rope is pulled with force of 30 Newton? What is the force? 30 Newton. The second thing that we need to remind is hollow cylinder. It is a hollow cylinder. So friends, if you are clear with your concepts, if you are clear with your basics, you must be knowing the moment of inertia for the hollow cylinder, and all we need to know is the moment of inertia for the hollow cylinder and the formula for the angular acceleration, what it is, and we can solve this question very easily. So now look at the solution. We know that force is given as 30 Newton. Torque, that is tau is equal to F cross R. That if we will simplify that, it will open up to Fr sine theta, and theta is the angle between the application of the force and the perpendicular distance. Since it is a hollow cylinder, so there is an angle of 90 degree between that, so sine 90 degree will become 1. So we will have tau is equal to Fr, and for the hollow cylinder, moment of inertia is mr square. We are knowing that, we have revised the formula, we know the formula, and we are going to hit the exam and crack it with the beautiful marks, with the flying colors. Okay, so now the angular acceleration alpha from the formula tau is equal to I alpha. Alpha is equal to tau by I. Put the value of tau, what it is, Fr. What is the value of I? That is mr square. R get cancelled with R, so we are left with F upon mr. F is given, m is given, and R is given as 40 centimeters. So 40 into 10 to the power minus 2, that will convert it into meters. So alpha is equal to 100 by 4 is equal to 25 radian per second square. Again friends, if you are clear with your basics, you will know that these two can't be the answer because they have the wrong in it. So you can automatically eliminate these two options, third and fourth, and we are having the second option as the answer. So now let us look at the next question. Acceleration due to gravity at height 1 kilometer above the earth is the same as the depth below the surface of the earth. Then d, it is asking the value of d. Again friends, now if you know the formula for the acceleration due to gravity at height and at depth, all we need to do is to equate those formula to find the answer. So acceleration due to gravity at height, h is g into 1 minus 2h upon r. For acceleration due to gravity at depth, d is g into 1 minus d upon r. Okay, so all we need to do is to equate this. So from equating this, we'll get that d is equal to 2h. So h is given, so we have the value of d, that is 2 kilometer. And now the next question is, consider a drop of rain water having a mass 1 gram falling from a height of 1 kilometer from 1 kilometer. Mass 1 gram. It hits the ground with the speed of 50 meter per second. Take G as 10 meter per second. G is the gravitational constant. So all it is we need to find is the work done by gravitational force and work done by the resistive force. Now it is much simpler problem, since all the options, uh, whenever we are trying to solve the problem, friends, go with the options, since for the first part all the options are different. So even if you are able to find the first part, we don't need to find the second part, we can automatically take the answer. So we all know that the work done by the gravitational force is mgh. So m is given as 10 to the power minus 3 kg, converting it into kg. J is 10, h is 1 kilometer it is given, so it is 10 to the power 3 meters. So work done by gravity is equal to mgh. M, putting the value mgh, we get 10 joule. So 10 joule is the only option we are having, only one option as a third option, so we'll get third option as the correct answer. For the sake of finding the other answer also, I'm telling you the solution for the work done by the resistive force. Okay, so work done by gravity plus work done by resistive force is equal to change in the kinetic energy. This is the basic formula we know, so we have already find this, put the value, we need to find this is the variable, and change in the kinetic energy is equal to half mv square. Half is there, m is from here and v is here, so square is 50, square is 2500. Putting the value, will get 10 plus work done due to resistive force is equal to 1.25. so work done by the resistive force is minus 8.75 joule. So now let us check in the option whether it is given or not. Yes, it is given, so third option is the correct answer. So so today we'll wind up with all these 5 questions. So now let us look other questions in the next lesson. I hope you learned and enjoyed. Thank you for watching this lesson. You can follow me on unacademy.com. This is my ID, unacademy.com/user/Vikas Joshi official. Rate us, comment us, and share the lesson. Okay, because पढ़ेगा इंडिया तभी तो बढ़ेगा इंडिया. Thank you.